Hello everyone. In this video, I'm just going to talk about a Snowflake schema, which is another technique for data modeling, which is very commonly used along with the star schema. This part is in a continuation to the previous one. If you haven't watched, if you are interested in understanding what is star schema, I would highly recommend you to watch that. Even if you don't want to watch it, and if you are here just for Snowflake schema, then you can continue that because this Snowflake schema actually utilizes the same foundation what the star schema has given to us. So in a star schema, right, what happens is we have this star-based, connectivity between, our fact table and the dimension table. But those dimension table are most of the time you will find are not completely normalized. But in a Snowflake, whenever we have a complicated database, which you can see on my screen, here we have a single fact tables which are connected with the four different dimensional table like product, customer, date, and store. And these product, store, customer, and date are further is getting having some multiple child tables. You see for customer, we have customer city and a customer country. For date, we have a month and quarter. For product, we have a product category, product details, we have product color and product size. So what we are trying to do, we are trying to normalize the data for the dimension table as well. Why do we need it? Majorly, whenever we have a storage constraint or we have a larger volume of database, which normally happens in real time, then definitely we have to go for the Snowflake. The only negative side is your join is going to be more complicated on your fact tables when you are going to extract the data for the data visualization, right? That is what we're going to see in today's video, right? So now it's from the definition perspective, Snowflake schema is a dimensional modeling technique where dimension tables are normalized into the multiple related tables, which I was just explaining to you right now with this example, right? Okay, so creating a structure that resembles a snowflake when visualized. So basically now what we're going to do is we are going to, create the entire snowflake schema based on the same structure what you are seeing here, like for fact sales table, which are going to connect it with the product, customer, date, and store. And then these product table are having four different, dimensional table. So we can say dimension product is going to be a base table. Here store table is going to be a base table, which is connected to the store city, country, and region. So we are going to just create all those tables, putting a sample data, and then we will try to run some interesting analytical query to just get the data, which can be directly used by any data visualization tool like Power BI or Looker or Tableau. Right. So this is the Medium article which I have published for the Snowflake as well. If you want to see all those queries, you can always come to my Medium article. I will provide the link in the description below of a YouTube video. You can always see this. I have put a lot of explanation, like when you have to use the data star schema, when you need to use the Snowflake schema. If you want some theoretical conceptual knowledge, you can go through this Medium article thoroughly and you will understand everything. So now gets into the demo part, and today again I'm going to use the Postgres as a database with the Docker Compose which I have run. And here is I have already connected to the data platform DB. The very first thing what we're going to do is we're going to start creating our tables, right? So we have this base table which has dim date. So we are going to start with the dim date. So we can quickly come back here in our structure and see what all tables we need for the date, right? So for date, we need dim month and dim quarter and dim date, right? So let's quickly see. We have a dim date. We have a bunch of columns defined. Then we have a dim month, and then we have a dim quarter, right? So let's quickly run all these three in one go. Okay, so we got those three tables created. Now we are going to move to the store one. In the store, we have region, we have a country, then we have a store city, and then this is our base table where we have some foreign key relationship to the child table. You will see this for the date. We haven't yet established any relationship, but that is not needed for this video. But maybe we will just do it in the later stage. Right. So let me just copy all these three-dimensional table along with the base table for the store. And let me run this. So now we have 7 tables. The next thing is we're going to target is the customer one. So in customer, if we just go back to our diagram, we have 2 dimensional table and 1 base table. So dimensional table is related to city and country. So what actually, if you just see the structure of this, it is actually just going to remove the redundancy which we're going to have in our database. and it is going to, optimizely store our data. This is what the normalization actually does for us. So whenever we have a hierarchical data structure where the tables are related to each other, then definitely we should go for Snowflake. Right. The last one is related to the product. We have category, product size, product color, product detail, the fourth dimensional table, and then we have a one base table where we have 4 foreign key relationship for all those dimensional table which are needed for the product. So I'm going to run all these 5 this time. You can use any database or any tool you have. I always love this command prompt. That's the reason I'm just doing this. Okay, so now we are done with all the dimensional table, the base table, and the corresponding dimensional table, or we can say a parent-child table. Now we reach to the point where we have to stitch together all the main 4-dimensional table, which are a base table, like dim prod, dim customer, dim date, and dim store. But in the context of the fact sale, these 4 are the dimensional table. So for that, what we need is we need this table right here. You can see, if you just see the foreign key relationship, now this foreign key relationship is for our customer table, our product, store, and dim, whereas our base table was having a foreign key relationship to our child, right? So if once I just run this, then we are going to have a similar structure what we are seeing over here. So we have just mimicked and created, the same structure what we are seeing here with the same relationship. And now we are going to load the data. So you can read through this Medium article and you will get all the queries which I have used in this YouTube video. You can just copy paste from here as well, right? So the next thing is just to put the data. So I'm just going to put the data in all the tables. So I'm starting with the quarter table, then we have a month, then we have a dim date. Likewise, the store related tables and all this stuff. So I like to just copy this entire thing. You can also get the same data in the Medium article. Okay, so let me just paste it here. Okay, so now we have enough data inserted, and now we reach to the point where we can directly run some insights on our fact tables, right? So here, how is our store performance broken down by the region and the country? If we want to extract that information, what we need, we are going to extract the data from sales. But as I mentioned, in Snowflake, still you have to make few joins, with your dimension table, depending upon what kind of information eventually you want to extract, because you need a store region, you need a store country, and definitely that information is not here. So definitely get these information or store name, you have to make a join. That's the reason you can see we have a join with a store country, and a store region, right? And then we have a group by and order by. So that's, I think you will be aware. So let's quickly run this query and see what we want, right? So now what we are getting a store region, Asia Pacific, a store country, Australia, store name, total orders, total revenue, and total profit. And now likewise, you can run any query, whatever you want. The next one is, what are our most profitable customer segment in each country? Again, same query. We need a customer segment. So definitely we are going to join with the customer. We need our address country as well, country name. So definitely we have to make a join with the customer. These are a very basic SQL fundamentals. Whatever the data you need, you have to make sure like you are having a proper join to those tables. And as I mentioned that in this, we're gonna have little bit of complicated joins. Okay, so I think I just made a mistake while copying it. I can quickly where the problem is. It says in a line number 1, business value, where seems like I just made a mistake while copying it. So I can quickly come here. Choose. I can quickly search by this data and see it. Just a problem. Okay, so this should be the query. Let me just copy this. Okay, now we are getting the data. Okay, so we can just see, I mean, which customer will be just not somehow, but I think I can run the same query here. So you can see. So here we can see the data in a more organized way. So here we have this customer segment, customer in this country, customer count, total orders, which customer has, the most spend, which is 519 from Australia. So we can just get any insight whatsoever we want, so you can write any queries. I mean, we can just write again this query. What it does is just provide us the product colors on the side of driving most revenue. Again, we can run here. Again, we can see which color. So black color is the most famous, or basically the people like black color most. When it comes to the electronics goods, when it comes to the footwear, then it's a white color. So these kind of insight you can get, and accordingly you can strategize your marketing strategy or whatever you want. There are a few interesting ones, the quality and the performance of data, if you really want, with more tables ensuring a referential integrity. So you can run some validation query as well to see whether there are data which is not having a correct, values. So you can simply say like whether you have something where the product ID is null or not. So you can quickly run this query. So likewise, you can just create as many as query you want to just validate that quality of that data as well. So right now there is no product ID which is null. So now we can see this, right? Now fact sales. So that's an important one. If there is any null value in your product, you can always go and correct it. So likewise, you can just write some more queries as well. So this is how you can just build this Snowflake based schema, right? And there are a lot of interesting information I put it in my Medium article. So I would highly recommend you to just watch that if you really need to get a more detail apart from what working demo I have covered in this video, right? So for example, if you want to see when to use a star and when to use Snowflake schema, wherever the performance is critical, user requirement, if you don't have a very technical folks and you want to give them a very simple queries to be written, then definitely you should go for a star schema, right? And definitely you have to make sure that there is no concern from the storage perspective. That's what I said. If there is a storage concern, then definitely you should go for the Snowflake, because it is going to make your model more normalized to just reduce the storage capacity, right? Then the data integrity, again, where the data integrity is priority, then definitely you have to go for the Snowflake, and which is quite obvious based on what we have understood so far, right? Because we have to make a lot of relationship between the tables, right? And that is why we are getting this complicated structure. So there are a few more, like it is ETL efficiency, scalable architecture. You can just read through all those content. I have already covered all these scenarios. And some more important thing, like what all analytics queries you can run with the whatever the setup we have created. So there are 20 very interesting queries which you can just run based on this simple architecture. And if you want a more analytical capabilities, definitely you have to add more dimension tables, your more base table, and just get connected to your fact tables. Or if needed, then you can build some more fact table as well, depending upon how many data marts you have, right? This one is definitely for sales. You can create another data marts where you can have a same data kind data model that can be mapped to your data visualization tool as well in a real time, right? So that's it from my side for this particular video. If you want to get more information around it, you can always reach out to me through the comments in my video, or you can just directly reach out to my email as well if you want any kind of help or any kind of supporting material, so that you can understand the Snowflake and star schema in more detail. I would love to help you guys on that. Right, so that's pretty much it from my side, which I want to cover in this video. If you have any concern, any additional thing you want me to cover, from this data modeling perspective, because I will going to publish another video where I will be covering a data vault, which is another complicated data modeling strategy along with the star and the Snowflake schema. So that would be published in a next video in maybe today or next few days. I'm just trying to collect the data and the working setup for it. Okay, so once again, thanks for watching this. As always, if you really like this video, give a thumbs up. And if you haven't subscribed for my channel, please subscribe for my channel as well. And once again, thanks for watching this. Stay healthy, keep learning new things, and be curious as much as you can be.